Hi everybody, I'm getting ready to record our first video together. Just let me get everything set up here. All right, so our first class, one of the things I talked about to begin with was what are some of the things that will be a normal part of our classroom routine? We call those classroom norms. For one thing, when you walk in the classroom each day, if you take a look at a whiteboard on the right hand side, you're going to see that it gives you a chance to know in an outline form what we're going to be covering each class. Any assignments that might have been due, if you're having a quiz that day, what the objectives are. It's a really good place to check when you come into the classroom and sit down for the first few minutes. Definitely, you will be asked to work with other people as well as working on your own, of course. You'll be asked to discuss ideas with a partner. Now, there are lots of different reasons why we do this, but really it comes back to the fact that it is known that you actually learn better when you begin to talk about something, when you have to explain an idea or sort out what is happening with another person and show them what your new ideas are or your new vocabulary, that it actually helps you to learn. So, as a result, you will definitely be working with a partner. You'll also be working in groups at times and by yourself and as an entire classroom, but just so that you understand that working in partners is a really important part of learning. Now, when we're in the classroom, we do more than just study math ideas. Of course, we have content material that we have to understand, things, terms, and ideas and strategies that you will learn. But beyond that, you will also be given some ideas on how to become or how to create an organized system of recording your work and some study skills that will help you be successful in the class. It's not just because it's a personality trait, it actually does give you a chance to really understand things and be more successful in the class. If I can help you develop a mind that looks not so much like this one, but looks like this, then you'll be able to access the ideas in the class much more successfully. As Benjamin Franklin said, and Benjamin Franklin is credited with first discovering electricity. He wrote, "For every minute spent organizing, an hour is earned." No question, Benjamin Franklin had it figured out that if he could spend some time on the front of organizing himself, it actually gained time for him in the end. It's not just that organized people are too lazy to look for things, and it's not just that we don't have a good arm good enough to throw it off our desk. Being organized really helps you be more successful in a course like mathematics. There are going to be two parts to organizing your class, and that is a notebook and a binder. In the notebook, we're going to be storing things like vocabulary from the day, explanations, examples. And in the binder, we'll be recording or keeping track of all the things that we use. So, homework and handout assignments, assessments, and something called a concept map, which we will use towards the end of our unit. Now, when we're working on notebooks, I want to take a closer look at what it means to actually take good notes. You know that it's going to include these three things: vocabulary, explanations, and examples, the things we do in class together. But let's take a look at what good notes look like. The following is an example, it's taken from my history class actually, of notes that are very easy to read and therefore easy to access. If you stop for a moment and looked at what are the things that you see that are good ideas in here, you would see things like color. Using color pulls your eye to look at certain things. Putting boxes around ideas or comment bubbles or conversation bubbles, all those things help to separate the ideas and bring them out and help you to focus on them. The use of arrows and question marks and little symbols and then writing in point form as well. And this is something that maybe is obvious, but it's a really important one. And that is putting space, giving space around an idea helps draw your eye to it and makes it so that the notes you take are that much more likely to be useful to you if we use some of those strategies. Okay, now let's take a look at what we're going to be looking at in this next unit. We're going to look at systems of linear inequalities. That's a mouthful. It looks like something like this. Now, as you go through this, you're going to be answering questions like the following: how could you use a linear inequality to figure out how many items you can afford and what it would cost? Now, you may look at something like that and think, I don't even know where to begin. Like, what does this picture have to do with that question? And how does it have anything to do with anything useful in this life? So, in this unit, we're going to look at that. We're going to study the math behind it and the ideas, and we're going to practice applying it so that you will see just how useful systems of linear inequalities might be. Here's a simple example. Here's a photo of a small convenience store, and it looks like a specialty store in some ways. He's got some sun-dried tomato pesto. He's got some salted capers. You can see some jam and olive oil up on the counters. So if I were to say to you, okay, you've got $20 in your pocket, go into that store and buy as much olive oil as you can. Well, once you figured out what the price of the olive oil was, you should be able to figure out the math and think, okay, I could probably afford 2 or 3 bottles, and out you would come. There's one answer to that particular assignment. However, if I were to say to you, all right, I need you to stock up, buy as much olive oil and jam as you possibly can with that $20 bill. Well, now you're going to have a variety of answers. You might buy more olive oil than you do jam. You might buy one of each. You might buy more jam than olive oil. Who knows what you're going to do because there's more than one answer. Now, systems of linear inequalities can help us take a scenario like this one and put it into a visual algebraic diagram that gives us an immediate access to what our answers and solutions could possibly be. Here's another scenario. So let's look at this one. Marnie has 2 part-time jobs. She earns minimum wage working at the information desk, and then $4 above minimum wage when she helps her mom with her cleaning business. Now, she enjoys the work at the hospital more than the house cleaning. Her mom has said she has to help, though. She never works more than 15 hours a week because she's got lots of homework, and she plays on her school volleyball team. Now, here's the question. Assuming Marnie has to work a little bit at both jobs, both at the hospital and with her mom, how many hours can she work at the hospital and still earn at least $160 a week? Now, we have to get some numbers ready, and I think in class we decided minimum wage would round it off, so we were going to say minimum wage was $11, and that meant her mom's wages were 15. So then we talked about what were the different possibilities, and the truth of it is there are a whole bunch of them. There's not just one answer. Marnie can do a whole bunch of different combinations of her schedule and how many hours she works at the hospital and how many she works for her mom. As long as you keep it within 15 hours and she has to earn at least $160, there are lots of different possibilities. Now, once again, a system of linear inequalities would give you an algebraic picture of this so that you could very quickly see, just by looking at a quick graph, exactly what the solutions are to this scenario. All right, so here you have it. Let's make sure you have recorded this in your new notebook. This is Unit 1. This is Systems of Linear Inequalities. And we're going to be taking a look at the first part where we review. Today, we're going to review graphing linear functions, and then we're going to move into 6.1, which is graphing linear inequalities, so that you're ready with all those tools that you need. The objective is simple. How do we solve problems? By modeling linear inequalities. Now, we're going to review some of the ideas that we're going to need, the background knowledge we need from things that you have learned before. So first of all, what is the equation of a line? All of you were able to come up with that for me on the last class that we had. Y is equal to mx plus b is the standard form of the equation of a line. Now, an important thing for you to recognize is that the fact that x is to the power of 1 is what makes this a linear function or a line. If it had been x squared or x cubed or the square root of x or the absolute value of x, any of those other options are going to give you a different graph. X to the power of 1, like the one you see here, is a line. All right, after that, we know that this is called the slope-intercept form because the slope is the number that sits in the front of the x, and the number beside it is the y-intercept of the line. And that makes drawing a graph very fast and easy. So let's review that. If you were asked to sketch this line, Two things you'd want to be able to pick out. Here is your y-intercept, -6, and your slope is 3 over 5, meaning you go up 3 and over 5. Let's take a look at that on a graph. Here's the -6 as my y-intercept. I go up 3, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. And then I have a line. This line has a positive slope because it rises as it moves from left to right. Next example. Again, in these videos, by the way, I would want you to pause and just try each example as they come along, and then you can take a look and see if your work is on the right track once you had a look at it. Okay, so with this one, we see that there's a y-intercept of 1. So you see I've put a point on the 1, and our slope is -4. Down 4, 1, 2, 3, 4, and over 1. And you have now a slope which is a negative slope falling from left to right of this linear function. Okay, now sometimes you're going to need to remember how to rearrange the equation in order to be able to use it in a graph. And so it might look something like this, where you have the x's and the y's on one side and a number on the other. So we do not have y by itself. And so we have to isolate y in order to be able to figure out what the slope is and the y-intercept. So we do that work first. Move the x over, divide by 3, and then we finally have what we need. So an intercept of 4 and a slope of up 1 and over 3. Here's another sort of hitch that they can put into an equation, and that is that they give you fractions. And fractions are not impossible, but they are a bit tricky and it's easier to make mistakes. So I wanted to make sure that you knew how to get rid of fractions. So if I've got a fraction, as in this case, with a denominator of 2, whatever the least common denominator might be, I'm going to take that number and multiply everything by it. I'm going to multiply this by a 2, this by a 2, and that by a 2. And when I do, it simplifies to the equation that you see below. Then I go ahead and isolate for y. Move the 2x over, divide by 7. And then, lo and behold, I have a really easy answer. Now I know my y-intercept is 5. I go down 2 and over 7 to get a graph that looks something like the following. Now, another question, just to see what you remember from last year. If you have two linear functions that are parallel, what do you know about their slopes? All of you very quickly told me that you knew that the slopes were equal if the lines were parallel. And then, if the lines are perpendicular to one another, you know that the slopes are negative reciprocals of each other. Now, that gives us enough information to be able to actually answer the following questions. So let's graph this linear function. It's going to go through 4 and 3, and it's going to be perpendicular to this one. Now, the slope here is -2 over 3. So the slope of the perpendicular line will be a positive instead of negative, as this one is, and we'll flip our numbers, so it'll be 3 over 2. Now, let's take a look at it. First of all, I put the point in place. Here's 4, 3. And then I used my slope, which was positive 3 over 2. So let me see. I went up 3 and over 2, and there's my line. Now, when they ask you to find the equation of this line, that means we're going to be using this form. This is a different form of a linear function. We call it the point-slope form. So we're going to substitute in our y and x values, and we're going to put in our slope. Now, you'll notice once I did that, I've actually substituted them in place here, that I then got rid of the denominator once again. You didn't have to here, but I just wanted you to see it because sometimes it will give you something a lot easier to use. So you'll see this next line that I've multiplied everything by 2. Now you'll notice when I multiply this guy by 2, that the 2's cancel, and all that's left is the 3 that I need to multiply by everybody else. And so we start to move things around. We get our numbers. Now we should be getting an intercept of -3. Now I cut this off before I got there, but definitely looks like it's coming at -3, and we know that the slope is 3 over 2. Okay, Now, in all of the ideas that we do, algebraically speaking, we have to learn the algebra, so we've got the tool to do things, but then we're going to be applying it to something that is a real life scenario. So let's take a look at that now. This one talks about a company that does paint jobs on cars and trucks. Now, there's a limit on how much the workshop can actually handle and produce in a day. So let me see where it says the daily output for the company is 7 vehicles in one day. They want you to write a linear equation that models the information you've been given about this workshop and then sketch the graph. Now, this one, as I said in class, this one's a little unusual because it's so what's happening here is it's so simple it sounds hard. And so I don't want you to think that it's harder than it is. So let's take a look. First thing you want to do is assign an x and y value for what you see. Let x be the number of cars that this workshop creates, and let y be the number of trucks. Well, if that's the case, if we know they make 7 vehicles in a day, then we know what they're saying is x plus y is equal to 7. If I move that around, then what I have is a linear function that will describe the output of cars and trucks. Now remember, the x's are cars and the y's are trucks. Now you'll notice as well that I needed to use dots, not a solid line for this linear function. You'll see there's my intercept of 7, and then I went down 1 and over 1 to get the next point. The reason for that is what we are talking about here are vehicles, and so we're not going to be talking about half of a car and half of a truck. So we've got very concrete, discrete answers, and so we use dots instead of a line. And all it's showing us is the different combinations of what this workshop could do. For instance, let's say we went over to this point, which is 4 and 3. What that means is they've done 4 cars and they've done 3 trucks. Whereas here, they've done 6 cars and 1 truck. All right, so all you're seeing are the different possibilities of what they can do. Okay, so the objective of this lesson was leading us towards solving problems by modeling linear inequalities. That's where we're headed with this particular work. Your homework is a worksheet, and you're going to see that on the Google Classroom. When you sign into that, you'll find it there. And I wanted to just say a quick word about how to best use your homework. Homework is not meant to be mindless activity. It's something that we want to do and use it well. So these are the guidelines. Try every question. Correct your work. You'll always find that there are solutions attached to the assignment that you have as well. So do your work and then check to see if you're doing it the way that I'm looking for. Circle the questions that you need to ask about in class. And always, when you're isolating something that does not make sense to you, always make notes when you piece something together. These last 2 things are the things that make your work worthwhile. And I will be stressing this a lot as we work together. You will hand in your homework each day, so make sure it's on a piece of paper. And when I give it back to you the next class, you'll be storing it in the binder in that section that you had for homework. All right, so there you go, everyone. That is the end of our first lesson. See you soon.